All right, in this video, we're going to talk about Chapter 7, Sections E and F. Now, Sections E, F, and G really are just giving you new terminology and new things that you can figure out from your truth tables. So you don't really, like, once you know how to do a truth table and you know how to determine the truth values of the main operator, you've got all the technical skills you need. These sections are just about how to apply and use a truth table, how to interpret its results to tell you things about the logical relationships between different statements. So the first terms that we want to learn here are contingent and non-contingent. Now, a contingent statement is a statement that's neither necessarily true nor necessarily false. Sometimes it's true and sometimes it's false. And you can use a truth table to determine whether a statement is contingent or not. So if a statement is a contingent statement, there will be at least one line on the truth table under the main operator that is true, and at least one line that is false. With non-contingent statements, the main operator truth values are going to be either all true or all false. So there are two kinds of non-contingent statements, tautologies and self-contradictions. In a tautology, all the lines on the truth table underneath the main operator will all be true. True, 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 true. With a self-contradiction, all the lines on the truth table will be false. So you got contingent and non-contingent statements. Contingent statements are going to have a mix of true and false truth values. Non-contingent statements are either going to be all true or all false. If they're all true, they're tautologies. If they're all false, they're self-contradictions. So here's an example of a tautology. And look at this one over here. Here's the main operator, it's the wedge, and underneath the main operator, you've got true, true. It's all true. No matter what the truth value of P is, this compound statement is true. So it's a tautology. It's necessarily true. On the other hand, look at this one over here. The main operator is the dot, and underneath the dot, you've got false and false. It's self-contradictory. If you look at these different compound statements, it'll make sense. Like, the statement here is P and not P. Like, I'm in South Carolina and I'm not in South Carolina. That's a self-contradiction. It's always false. Those can never both be true. On the other hand, look at the tautology, P or not P. Either I'm in South Carolina or I'm not in South Carolina. That's always going to be true. There's no middle way. There's no way for that to be false. So that's a necessary truth. That's the idea of what we're talking about here. So here's another example. If you got this compound statement, and let's say we build out the truth table for it. Here's the main operator is a horseshoe, and under the main operator, we've got false, true, true, true. So is this statement contingent or is it non-contingent? That's right. This is a contingent statement because it's got a mix of falses and trues. It's neither a tautology nor a self-contradiction. Okay, we'll do 7F in the next video.